Welcome to Ms. Parb's classroom. In this lesson we're going to talk about direct variation. And the objective of today's lesson is to understand the meaning of direct variation and apply it to write equations and solve problems. Anytime you see a star, that is something that's really important that you need to make sure you write in your notes and that you understand it and know how to use it. So you would write some quantities are in a relationship where the ratio of corresponding values is constant. In other words, for every ordered pair, x and y divided by x equals some constant k, and k is the constant of variation. And this would be true for every ordered pair except the ordered pair 0, 0. First problem we want to look at is this relationship a direct variation? And if it is, we want to write the function rule in the form y equals kx, where, remember, k is the constant of variation. So we look at this table and we take our y value, which is 2, and divide it by our x value, which is 1, 6 divided by 3, 8 divided by 4. When we divide each one of these ordered pairs, we always get the number 2. So yes, this is a direct variation problem. The constant of variation is 2, and we would write the rule as y equals 2x because 2 takes the place of k. In this example, our y's are 4, 8, and 11. Our x's are 1, 2, and 3. 4 divided by 1 is 4. 8 divided by 2 is 4. However, 11 divided by 3 is 3.6 repeating. Since these are not all the same, this is not a direct variation. Okay, anytime you see got it, those are problems that you should copy in your notes and try for yourself, and pause the video, and then once you're through, start the video again and check your work. So now pause the video, copy these two problems, work them out, and then start the video again. In order to determine if this is a direct variation, we have to take the y and divide it by the corresponding x. When we do this for the first ordered pair, we get a negative 7. When we do it for the second ordered pair, we get a negative 7. And when we do it for the last ordered pair, we get a negative 7. We get the same number every time, so we know that k equals a negative 7. This is a direct variation, and the equation would be y equals negative 7x. In the next problem, we do 5 divided by 2 to give us 2.5. We do 7 divided by 3, which will give us 2.3. Already we can see that these two numbers are not the same, so this is not a direct variation problem, and we can stop there. Okay, the equation for direct variation is y equals kx. It's like the linear equation y equals mx plus b when b is 0. So if you had a linear equation that went through the origin, it would be a direct variation. So you're already familiar with this, and notice the similarities. Okay, so for each function, determine if y varies directly with x. If so, give the constant of variation k. Well, the problem is 3y equals 7x. And to determine this, we want to solve for y. So we divide both sides by 3, and we get y equals 7 over 3x. This is in the form of y equals kx, and we know that k is our 7 over 3. So yes, this is a direct variation, and the constant of variation is 7.3. In this problem, we have 7y equals 14x plus 7. We solve for y by dividing every term by 7, which gives us y equals 2x plus 1. This is not a direct variation because this has to be 0 in order for it to be direct variation. Okay, another got it? Pause the video, copy and work the problems, and then start it again to check your work. Remember, the first thing we want to do is solve for y, so we're going to subtract 5x from both sides. And that will leave us 3y equals a negative 5x, because when we add 0 to anything, it doesn't change. Then we'll divide by 3. Y equals a negative 5 over 3x, which is in our form of y equals kx. So this is direct variation, and k is equal to a negative 5 over 3. This next problem is already in the form of y equals x over k, but we need to find the constant of variation. So if we divide both sides by x, we get y over x equals 1/9. So we know that our constant of variation is 1 over 9. Okay, let's look at this word problem. Suppose y varies directly with x and y equals 9 when x equals 3. What is y when x equals 21? I'm going to show you two different ways to work this, so you can use whichever method is easier for you. The first method is a ratio. For every ordered pair, when I do y divided by the corresponding x, remember I should always get the same number. So I can take this information and just set up a simple ratio. When y is 9, x is 3. So y divided by x is equal to this y divided by our x of 21. Cross multiply to get 9 times 21 equals 3y. Divide both sides by 3, and you get 9 times 21 divided by 3, which gives you y equals 63. So your answer would be when x is 21, y equals 63. The second method is to solve for your constant of variation, which is k, and then use the equation y equals kx to solve your problem. So we know k equals y divided by x, so we take 9 divided by 3, and we get 3. And then we take our equation y equals kx and plug in the information that we know. So we know y equals, k is 3, and they tell us x is 21. When we work that out, we get 63. So when x is 21, y is 63. Same answer, same problem, two different ways to work it. Okay, the got it problem for you to try. Y varies directly with x, and y equals 15 when x equals 3. What is y when x equals 21? If you want to use the ratio method, you would take your y divided by the corresponding x and set that up to your other coordinate, which is what is y when x is 12. Working this out, we would have 15 times 12 divided by 3, which gives us y equals 60. So we know when x is 12, y equals 60. If you want to use the second method, solve for k. K would be equal to 15, your y value, divided by the corresponding x. So k is 5. And then we want to find y. So y equals k times x, multiply that out, and y is 60. So regardless of the method you choose, you still get when x is 12, y is 60. Let's look at this word problem. A salesperson's commission varies directly with sales. For $1,000 in sales, the commission is $85. What is the commission for $2,300 in sales? Well, commission, because we say we want C to be commission and S to be sales, commission varies directly with sales. So if you recall in the problems we just worked, this would be like y varies directly with x. So we know that if we want to set up the ratio, C, which is the same as our y, over S, which is the same as the x, is equal to the other point. So we're going to take 1,000 in sales and 85 in commission, and that will be equal to, this 2,300 takes the place of sales, and we solve for commission, and we get $195.50. Once again, if you prefer the second method, you're going to find K and solve it. You know that 85 is equal to 1,000 K, because your commission is 85 when your sales are 1,000. So K is equal to 85 divided by 1,000, or 0.085. Then you plug that back in. Your commission is 0.085, your constant of variation, times your sales, which are 2,300, and once again, you get 195.50. And the last thing we want to look at is graphing a direct variation. And the question is, what is the graph of each of these direct variation problems? Remember, we already talked about how this K is the same as our slope. So we can just graph this by starting at the origin. Our slope tells us to go up 3 and over 4 to find our second point, and then draw the line. In this one, y equals a negative 2x. It always goes through the origin, so we start at the origin. A negative 2 slope, remember that's a negative 2 over 1. So we go down 2, and then we go right 1, put our second point, and then draw the line through the 2 points. On the got it, once again, for this problem, you're going to start on the origin. This direct variation will always start with the origin. We're going to go down 2, and then we're going to go right through. Put the second point and draw your line. And the last problem, y equals 3x, start at your origin. Remember, 3 is 3 over 1, so we're going to go up 3. We're going to go over 1, put our second point, and draw the line.